Okay, we are picking up with series. So sigma notation, and sigma notation is this funky E we're seeing down here, just means add. That's all it means. And so the sigma notation is going to tell us to add terms in a sequence, and that is called a series. So basically, we could have some rule that is a sub n. By the way, n and I can be used interchangeably. You can actually use any variable you want as long as they match. So a sub n is equal to 4n minus 4. So this is the rule for the sequence. For the series, we want to add terms for that sequence. So what this particular notation is telling us is that we are going to add, that's what the E notation means, and then we have I equals 1 below, which means from the first term up to the fifth term, and how we get those is by plugging into our rule for I minus 4. So for our first position where we have this 0, we have 4 times 1 minus 4, which is 0. And then we do the second term, 4 times 2 is 8 minus 4, which is 4. And so then the series is adding all of these up. So 12 plus 12 plus 16, so 24 plus 16 gives us 40. So that would be the sum of the series. When we're asked to find the partial finite series, it just means we're going to be adding up the number of terms they tell us to here. And finite means that it's obviously not going to an infinite number of terms. Sometimes we can have an infinite series. So basically we have negative 10 times 1 plus 70. That does not look like 70. There we go. Plus negative 10 times 2 plus 70. Plus negative 10 times 3 plus 70. And then plus negative 10 times 4 plus 70. Plus negative 10 times 5 plus 70, and then finally plus negative 10 times 6 plus 70. Hopefully we're not running out of space and you guys can see that. Sorry, I tend to use guys as a gender-neutral term. Hopefully you all can see that. If we add those all up, we end up with 210. Our next example is an exponential example. We have negative 2 to a power, so first is going to be to the first power. And actually, since every single one is going to be multiplied by 4, we can use the distributive property and pull that factor out. Again, we can only factor things out. We can't move constants away. But factoring that out for the distributive property, plus negative 2 squared, plus negative 2 cubed, plus negative 2 to the fourth, plus negative 2 to the fifth. And make sure you use parentheses. Remember, your calculator is only as smart as its operator. And for that one, we end up getting, I believe, negative 22 times 4, which is negative 88. We can write the series with summation notation, so we can find the series, which means adding the terms if we have the rule. This is like when we're finding the rule, we're finding the a sub n rule. So we want to find the rule that creates each term in the series so that we can show how they would be added. So first off, for this first series, 5, 10 plus 15, it appears that we are going up by 5s each time, and they actually seem to match up with the position. So our first position is like 1 times 5, this one is like 2 times 5, 3 times 5. So it appears that our a sub n equation would be 5n, right? So that would give us any term. So we're going to be starting with the first term, and again, you can use any variable you want as long as you're consistent. And then what term are we going up to? Well, I actually have to figure out what term 100 is. So I'm going to put 100 in for the a sub n spot equals 5 times n. And to figure out what position number 100 has, I just solve for n, which is going to give me 20. So that means that we are adding from the first term up to the 20th term. And since we are making the series, I'm going to make the switch from n to I. Remember, I and n can be used interchangeably. And we'll make this 5i. So that's how the series would be represented. For our second one, well, what's happening? 1/2 to 2/3 is not equal to the change between 2/3 and 3/4. Well, the numerators are just 1, 2, 3, 4, and it's position 1, position 2, position 3, position 4. So it looks like the numerator is just n. The denominators are going up by 1 as well, but they don't start with 1. They start with 2, so maybe the denominator is an n plus 1. So let's see. This one would be an a sub 3 position. So let's see. 3/4 equals 3 over 3 plus 1. That is true. Okay. So this would be n over n plus 1 would be the rule for the sequence. We're going to write it for our series. We're going to start with the first term. And then, well, this one doesn't actually stop. So above it has ... meaning there's a number of terms in between 15 and 100, but 100 is definitely the stopping place. We don't have one here, so we're going to actually just indicate that with infinity. We are going to add up an infinite number of terms. And those number of terms are found from the rule we found for the sequence. So I'm just going to make the change from n to I over I plus 1. This can also be written as n equals 1 to infinity of n over n plus 1 if you like that better. It really does not matter which variable you use. All right, well, that's it for the first day of online school. Hopefully everybody's able to access this. Hopefully you're telling your friends that I do have ways to contact through the Remind and whatnot if they did not get my email. This is the first assignment. I will also be putting it up on Gradescope where you will be submitting it. Thanks, and I hope you have a great day.